Hi students. In this lecture, I am going to discuss problems based on pressure and force. Let us see first one. See the question given. An isosceles triangular plate of base B and altitude h is immersed in a liquid of density rho with its base coinciding with the free surface of the liquid. Find the force by the liquid on one face of the plate. So given a plate, given altitude and its base. So we have to find the force by liquid on one face of the plate. Let us see how to start. So it is given now isosceles triangle and condition is that base is touching the free surface. So take now this is a free surface. So now it is a completely inside liquid. Now liquid exert a force on both sides of the plate. That means net force by the liquid on the plate will be zero because it exerts a force on both faces. So now here question is a force acting by liquid on one face. Okay, then see what we are doing. So we are taking now at a depth h, or take depth is y, because given here altitude is h. Let us take at some depth y, taking a strip of width dy. This is now dy. Now focus force acting on that strip. This is now one rectangle, right? Because here with depth, pressure changes. Therefore, here force acting on this one. Like this, we take all rectangles from y equal to 0 to up to y equal to h. Okay. Let us see force acting on this rectangle. Given base, it is b. Let us take now for this base length, take it as b dash. Now we can write force acting on the rectangle is, so take it as df, that is equal to pressure equal to p naught plus y rho g, that is pressure into corresponding area. It is now rectangle, its length is b dash and breadth equal to dy. Okay, let us see how to get the value of b dash. So coming to b dash, here you can take similar triangles. This is one triangle, bigger one, and this is now smaller one. This is smaller one. So in that we can write b dash upon b. I am taking here similar triangles. So bigger one and smaller one. So in that b dash upon b, that is equal to h minus y upon h. See carefully. Okay. So from this we get the value of b dash. Now substitute that here. So it is equal to p naught plus y rho g in the place of b dash. B upon H into H minus Y into dy. Okay. Like this, we have to take all rectangles and we have to calculate force acting on each rectangle. Then we have to take sum of all those. That means the force acting is equal to integration of df. That is now substitute that here. So P naught, or let us take now these things inside P naught into, or you can do one thing, take B by H. It is a constant, take outside. I'm taking it outside B by H. Remaining is now P naught into H minus Y into dy plus what else? Y rho G. So rho G. Remaining is now H into Y minus Y square into dy. Cross check once. P naught into H minus Y dy. Next, rho G into Hy minus Y square into dy. Like this, we have to take all rectangles from y equal to 0 to h. Okay. Now see calculation. B upon h, remaining part P naught into h. That becomes now h into dy. That is h into y, right? H into y minus y dy. Y square by 2 plus rho g into h into y into dy. It becomes h into y square by 2. So h into y square by 2 minus y square dy. It is y cube by 3. Right? Now see the calculation part carefully. F equal to, so B upon H outside. Remaining is now P naught. Substitute now limits 0 to H. It is 0 to H. It becomes H into H square. It is a H square by 2. Remaining is now H square by 2. H square by 2 plus rho G. So H square by 2. So H cube by 2. H cube by 3. It becomes now H cube by 6. Right. Now see the calculation part. H and H square, H and H cube. Remaining is P naught into BH by 2. Cross check once. One H gets cancelled. Plus this is rho G, and B is here, B is there, B rho G, H square. I'm taking this as, do one thing here, rho G, what is left here, H square by 6, right? Okay, now see the same thing, we can take it as B P naught half base height. This is now area of triangle. It is here. Plus, and this can be taken as, see, rho G. Now taking this as, so taking this as H by 3, H by 3, rho G H by 3 into, it is now half base height. Cross check once. Rho G H by 3. Okay. Remaining is now BH by 2. This is also now area. That means this is equal to P naught plus rho G H by 3 into area. Right? So how this is written as pressure into area, right? Area equal to half base height. And see where we have taken our pressure. If you see carefully, P naught plus OC H by 3. You can see this is now distance of center of gravity or center of mass from the base. So when you are taking a triangle, center of mass or centroid or center of gravity, it will be at a distance h by 3 from the base. So we can assume now this entire force acting at that point. So calculate now pressure at that point, P naught plus rho z h by 3 into area. So this result is helping us to solve problems. For example, question is given like this is one square plate. This is now just immersed. It is like this. Now calculate a force acting on one face of the square plate by the liquid. Then I can use now this result to calculate a force acting on the square plate. See, that will be equal to F equal to P naught plus center of mass will be at center of the square plate, right? So it is now if the side length equal to h, it will be h by 2 rho g. That is now pressure at this point into area. It's a square, so h into h square. So like this directly we can write. Remember here we have taken integration. In fact, we have to follow same process here also. At a depth y, take one rectangle, right? Then find force on each rectangle. Then take sum of all those things. Sum of all those things. And finally, we are going to get now the same result. So whenever questions are asked like this, so we can take entire force acting at its center of mass or center of gravity. Okay. Let us now focus on next problem. Let's see the question given. To what height a liquid should be poured into a cylindrical vessel of radius r so that force exerted by the liquid on curved surface is equal to that on the base, and condition given that neglect atmospheric pressure. Given a cylinder, to what height we have to fill it with a liquid. Condition is on the base and on curved part by liquid force must be same. Let us see now. So condition given that it is a cylindrical vessel. Cylindrical vessel. To what height we have to fill liquid so that force on the bottom and on the top both are same. Okay. Up to what height? Suppose now this is equal to height is h. So which we want to calculate, right? See how we are starting the problem. Coming to force on the base. This we can say directly. Force on the base, that is equal to at the bottom pressure equal to h rho g. Pressure equal to h rho g. H rho g. Coming to area, that is now pi r square. This is now force acting by liquid on the bottom of the cylinder, right? Next, force acting on curved part. On curved part, see what we have to do. on curved part. We can take the result which we got in the previous problem. That is, when height equal to h, center of mass will be at a height h by 2. Then pressure equal to, this is h by 2 means this also h by 2. So pressure equal to h by 2 rho g. This is now pressure into the corresponding area. So area of the curved part, area of the curved part, this length equal to h. So area equal to 2 pi r into h. This is now force acting on curved part. Now equate these two. So we are equating now this two. Then see what we get here. H rho g into pi r square, that is equal to h by 2 rho g into 2 pi r h. Okay. Now just see the calculation part. So coming to calculation part, see which we can cancel. Rho g cancelled, h cancelled, 2 and 2 cancelled, pi r cancelled. Here only r is left and here h is left. That means h equal to r. Okay. So directly using that result. For example, if you are not knowing this result, then say how to calculate force on curved part. If you are not knowing that result, then we are taking at a depth y, take a strip of width equal to dy. Okay, this is dy. Then see force acting on that at a depth y, pressure equal to y rho g into corresponding area, that is 2 pi r into dy. So this is giving us a force acting on that strip. Okay, force acting on that strip. Like this, we have to take all strips from y equal to 0 to up to h. So integrate y equal to 0 to up to h. That gives us a force on curved part. Force on curved part. So I can take here constants outside. 2 pi r, take outside. Rho g, take outside. Remaining is y dy. It becomes y square by 2. It is h square by 2. You can see same we got here. 2 pi r. Okay, 2 pi r. Rho g, rho g. Remaining h square by 2. H square by 2. So if you are not knowing that result, we have to calculate like this. Okay. So I hope you got the clarity. Let us go for next problem. Right. Figure shows a semi-cylindrical massless gate pivoted at the point O, holding a stationary liquid of density rho. Liquid is now stationary. This is now cylindrical gate. Okay. Length is now into the board. So it is appearing just like a semicircle. We are having this length is now into the board. The length of the cylinder is L. Calculate the horizontal force exerted by liquid on the gate. See, we have to calculate horizontal force by liquid on the gate. And you can see in diagram, this is 3R only up to here. Okay. Not complete one up to here. It is only up to here. 3R. So this is R. This is a 2R. Total is now 3R. Okay. That is diagram. Let us see how to calculate. Asking force by liquid, and that is only horizontal force only. Only horizontal. Let us see how to solve. So first of all, make a diagram. Okay, given diagram, it is a cylindrical gate. Cylindrical gate. So water is now. This is now water. It is like this. So we have to focus now horizontal component of force. You can see force by the liquid is always normal to contact. Suppose we are focusing now, we are focusing now somewhere here. Okay. Then by liquid force will be normal to that contact. It is now like this, normal to contact. It is having two components, horizontal and vertical. Now asking only horizontal component of the force. Okay. See here what I am doing. The result what we got in the previous problem. That is, we take pressure now. See, this is given as R. Okay. And we want to find pressure now at the center. At the center means depth equal to, this is R and this also R. Total is now 2R. So pressure now at a depth 2R, that is equal to P equal to P naught plus H is H rho G. This is now pressure. Okay. Now coming to the area, you should be very careful here. Here we are going to take projection area. So projection means it is a component. Okay. Let us see how we are taking that. So I'm taking here separately that semi-cylindrical gate. This is now semi-cylindrical gate. Length is now into the board. Okay. So it looks like a semi-circle. Now see what I'm doing here. Let let us consider one small strip. We are taking a strip. See carefully. Taking angle theta. Take a small change d theta. Then this length will be r into d theta. Okay. So here we are taking one rectangle of length L, breadth equal to r d theta. You have to see carefully. This is semi-cylindrical gate. Okay. This is now we are taking one rectangle. Okay. We are taking now one rectangle. For that rectangle length, how much? For all rectangles, length is L. Okay. And this is now its breadth r into d theta. Okay. Now see what I'm doing here. So I'm making diagram once again separately. This is now gate. We have taken one small part on that. We have taken one small part. Okay. One small. You see, it's a projection. It's a projection here. its length equal to r into d theta. Correspond to that, you can see projection here. This is now, see this area equal to L into r d theta. It's a corresponding projection, means it's a component on this one. This is now it's a component. Okay. Component of this area is now this one, right? The meaning of projection, it is a component. We are taking now for this area one component on the base. Okay. If I am taking one more here, it's a component on the base. This is the component. Like this, if I am taking all rectangles, take here one more rectangle, it's a component on the base. It's a component on the base. That means if you are taking all rectangles and if we consider components for those areas on the base, then we are going to get this total area. This total area means this will be 2r. This is 2r. And for all the rectangles, length equal to L. That means projection area will be 2r into L. So area of one rectangle is L into r d theta. Now its projection is now I have taken on the base. So if you are taking like this for each rectangle, it's a projection on the base. That gives us area of that rectangle. It is area of rectangle. That means it looks like this. This is one rectangle whose length equal to L, breadth equal to dr. This is a flat part of the semi-cylindrical gate. This is a flat part. So when you are taking projections on the flat part, we are going to get finally it is equal to area of this flat part. That is 2r into L. That means now horizontal component of the force by liquid on the gate is equal to pressure P naught plus 2r into rho g. This is a pressure into area. Area is now 2r into L. So remember, this is the projection area of this curved part projection. And we are going to use this logic in coming problems also. Okay. This is our final answer. Suppose in problem, if it is mentioned like neglect pressure of atmosphere, in that case, this becomes 2r into rho g into 2rl. This is if P naught is neglected. Okay. That means in that case, answer will be 4r square rho g l. Okay. 4r square rho g l. Right. So here main thing is to understand this is the projection area, how we have taken. Okay. If you are able to follow that, remaining is very simple. Right.